So let's bring it back to the beginning of the Databricks story. Can you tell us the founding story and how Databricks originally started in academia?
Yeah, I mean, we were working on a very sort of high-profile project at Berkeley. It was called Mesos at the time. And believe it or not, Spark was actually kind of like a hack that we put together just to demonstrate, because we were working on this project. It was called Mesos, and it was basically something to prove out that you could do scheduling in big data centers. But we didn't know how to prove to people, a scheduling algorithm, it's very hard to demo it to someone, right? It's like, oh, scheduling works. So we said, hey, we need to do a demo, something that makes people really realize what they're looking at. So Spark was just developed like that, just as a like a hackathon, just to prove. It was kind of like a proof of concept. And in fact, I even said it in the beginning, hey, this proof of concept, we shouldn't spend too much time on it.
Yeah.
But yeah, that proof of concept, which was initially just 5,000 lines of code, just became bigger and bigger and bigger, and it became much bigger than the original project that we were all working on. And soon we had investors come to UC Berkeley saying, hey, we should commercialize this. And we were actually not that interested. We were just interested in building software and open sourcing it and things like that. So we actually tried to get the companies at the time to adopt this open source software that we had developed, which was Spark. But they kind of wasted our time and said, oh, you guys are just grad students at Berkeley. You're going to graduate. You're not going to maintain this stuff. We don't want to use it. So we were really pissed off. So actually, kind of out of rage, we kind of started Databricks to just prove them wrong and beat those companies. So that's kind of how it started.
Wow. And you had 7 co-founders. What was that like?
Yeah, we were 7 folks. I mean, we were all at Berkeley. We were very similar backgrounds. We were basically system hackers. We liked writing code, and that was our attitude in the very beginning also. I remember at the very beginning when Ben Horowitz wanted to invest in Databricks, our initial sort of take was, we shouldn't let him invest.
Really?
And people were like, why not? And we're like, well, what has he coded? What has he done? He's just a VC, So actually, that was our initial take, that we wouldn't let him invest because he was not a coder. But then we said, okay, well, if he comes in with a really high valuation, maybe we'll let him invest. And I think one founder said, well, he had to value us at least at 30 million, and someone said a higher number. And then Ben came in to a meeting and he said, guys, I'm not going to negotiate with you. I'm going to give you one number, and you say yes or no, and then I leave. And we said, what's the number? And he said, 47 million. And we're like, okay. We shook his hands, we took the money, and the rest is history.
Wow, wow. Let's bring it to today. Databricks is one of the world's highest valued AI startups at a whopping 100 billion valuation. You're alongside the likes of OpenAI and Anthropic. For the many students that are out there in the audience, what makes Databricks one of the most exciting and best places to work if you want to build a career in AI?
Yeah, I mean, look, first of all, I think we're very open source and open focused, so it's exciting. We have the same roots as we used to have. Secondly, I think we're working on the most exciting problem that you could be working on right now. The most exciting thing that's happening, I think, is making AI actually work inside, in real life, making the agents actually work.
Are you saying AI doesn't work?
Well, so classic ML works great, right? People are using that for forecasting. But generative AI, and specifically agents, we're all very, very excited about it. But it is not the case yet that, inside every organization you have coworkers that are agents and they're doing work, and 5% are humans and 95% are agents, and we have supervisor agents that are managing, manager agents that are managing IC agents. That hasn't happened yet. It will happen, and that's what we're focused on at Databricks. So, and I think we have the best shot to make that actually work, because we have all the enterprise data, which is very sensitive. So that's the secret sauce you need to make these agents have high quality on the actual tasks that they're doing inside companies. So that's what we're excited about. We built this thing called Agentbricks that lets you basically build Databricks on the data that you have, and these agents can then automate the tasks inside companies.
So we'll dig in a little bit more to Agentbricks in a moment, but I want to stick on the career front. So you heard it here first. Databricks is tripling new grad hires this year. you've said that this generation is made for this moment in AI. What makes you say that? Why is it a great time to be young and a builder?
Yeah, I mean, I think this is the best time. I wish I was just, graduating from my undergrad degree at Cal right now, but I was born too early. The reason for it is that, I think this is like kind of like a renaissance. It's kind of like having been born in the 40s when the first computers came along. We have this new computer, which is basically the neural net, the transformer, the agents, and there's just so much innovation left to be done. When we looked at the stats inside Databricks, we basically looked at on the IC ladder, and we looked at people's tenure at Databricks, and we just noticed that people that have fewer years of experience are just embracing the AI tools much more. And with the much more senior people, we have to cut teeth. We're telling them, please use it, please try it. And they're like, no, it doesn't work, and it's gonna have errors, and I'm a better coder and stuff. They're sitting there in Emacs or Vim. So we kind of tell them no, just try it, please. So that's what we decided. Let's just bring in more, the grads, the people that graduate now, we call it NCGs, new college graduates. They come out. This is how they operate. They use these tools. They don't even question it. So that's what we thought. Let's just double down on that. Then we're trying to convince all the folks that have already been at Databricks for many years. It just seems very hard to get them to use this stuff.
So an AI native engineer, they're using all the tools that are available to them at their disposal, essentially.
Yeah, I mean, it's just they're parallelizing it, and they don't know how to efficiently. And I think they also work differently, because I think in this era, how you actually hack things together, how you operate is different from 10 years ago. So they're just native with that, so it's just much easier.
Yeah. So we're at a hackathon here. You're also an AI professor at UC Berkeley. What's some advice that you would give the students here on just how they can make themselves more and more competitive, if they're applying to Databricks or elsewhere?
Yeah, I mean, look, I think you guys are already doing all the right things. Work on the small, silly projects. In my career, whenever I saw any project become really successful, or whenever I saw anyone sort of have great success with whatever they're doing, whether it's companies or open source projects or whatever it is, it started as a very simple, silly idea. And when you ask them hey, how did you come up with this? They're like, oh, I just wanted to do this little simple thing. And other people thought it was so silly that they didn't want to even work on it. And then you just built this useful thing, and then the useful thing, you expand on it, and you keep iterating on it, and then over time it grows up to be this really big thing. So do that. You don't need the projects. Post hoc, once you're done with the project, it looks gigantic, like Apache Spark now. It looks like a massive project with 2 billion downloads a year, and it can do everything for you, and it's in 5 different languages. But it started with this tiny little idea. 5,000 lines of code, written overnight. Most projects start like that. It's a few thousand lines of code. So just keep doing that. Don't let all the pressures that are going on right now with you have to start your own company and you have to move fast and everything is moving so fast and all the jobs are going to go away and blah 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 blah. Don't listen to all that crap. Just focus on your ideas and just implement them, POC them, and expand from there, and great things will happen.
All right, I see you in the back. Maybe you're building the next Spark. You all are doing the right things by being here, so just keep doing what you're doing. Have fun this weekend. Let's shift gears a little bit. So, I want to talk a little bit more about the technology of today, the leading edge technology of today. There's a lot of hype around the frontier AI labs and these large models, but why are these models alone not enough to push forward our AI future? What else do you need?
Yeah, I think we need the kind of stuff that I suspect many of you will be working on over this weekend. I think there's kind of 3 paradigms going on right now. You have the frontier labs like OpenAI, Anthropic, and DeepMind, and they're really focused on the superintelligence race. How can we build artificial superintelligence? And a lot of it is about the scaling laws. Pour more money, more GPUs, and more data, and just see if you can get to this kind of super god. And if that's the thing you're chasing, how do you evaluate it? If someone told you, I invented God, here it is in front of you, how would you know that? Well, how would you evaluate it? What question would you ask that?
I don't know.
Well, you'd ask it the hardest question you can find.
What's the meaning of life?
Well, no, because it'll give you some cheesy thing that it's memorized, right? You ask it math Olympiad questions, physics Olympiad questions, programming contest questions. That's what they're doing, the labs are doing. So that's paradigm number one. And it's very capital intensive. That's why we're seeing these 100 billion, 500 billion Stargate projects and so on. There's a second camp, which are the sort of creators of the technology. I mean, this is like Jan LeCun, Rich Sutton, and these guys. If you actually talk to most of them, they're pretty skeptical to the first paradigm. They're saying it's not going to get us superintelligence. And many of them, if you ask them what you think, where is the future, they're going to say it's 10 years or 20 years out, this kind of superintelligence. They're more inspired by biology-inspired intelligence that kind of thinks more like us. I think the third paradigm is the most interesting. That's the one I think you should all work on. The third paradigm is, I think we already have AGI. I actually think we have achieved AGI. We just need to make it useful. So just apply it to everyday things that we want to do and make it valuable at simple things. And that's all we need. And that's what's going to prove out to be very, very valuable for everything, businesses, companies, organizations. We don't need more intelligence, honestly, to be, it's great that they're doing that. We'll see, it's going to be, they're going to continue doing that. And then so that's like very capital intensive. They're going to continue doing that. In the second camp, they're doing like really far out research. That's the second camp. But I think we have all the AGI we need. And I'm happy to define like why I think we have AGI. But
we have all the AGI we need. All right. Well, let's talk about some of the applications. You alluded to Databricks before that you launched recently to build and deploy agents within the enterprise and beyond. Let's talk a little bit about the state of agents and what is and isn't possible today.
Yeah, I mean, I just think that, if the focus has been on these program Olympiad, physics Olympiad, programming contest stuff, but what you want the agents to do today are just very simple tasks. In the simplest tasks that you can imagine that you want to automate, no one has evals on those. So the approach we took with Databricks is that the first thing Databricks does is it produces automatically an eval or an LLM judge for the specific task that you want to do. And then it lets you tweak and automate and make it enrich that test to make the LLM judge better and better. And then you can plug in any AI system that anyone built, and then it will tell you a score on specific tasks. So it's like just a very pragmatic approach on just doing evals on the specific tasks that you want to automate. That's step number one. Step number two, we then do search. Hyperparameter search. We look at different models, from OpenAI, Anthropic. We check different sizes. We do prompt optimization. We do fine tuning. We even run reinforcement learning. We do test time compute on top of that to find out of all these different techniques, which one gives us the highest score on that LLM judge on that specific task. And then we actually finally present many options to the person who wants to build these agents. So we'll plot it basically on a cost versus performance curve. So you can pick, I want to have very high quality and I'm willing to pay a lot for it. Or I want to, so you can look at that curve and you can pick wherever on the Pareto frontier you want to be. So it's just a more pragmatic approach to like just making these agents useful inside organizations differently from that paradigm one that's looking for the, the highest intelligence you can achieve.
Are there any examples from Databricks customers that you've seen deployed in production that seem particularly useful?
Yeah, I mean, there's lots. I mean, Merck, the pharmaceutical company, they built basically a model that lets you do basically go from molecules in their drugs that they're developing all the way to like genomes. Wow. So they can figure out, basically which molecule is responsible for which genotype, which then leads to the phenotype, which is the disease. So basically it can do better drug discovery. It's pretty awesome. Or Insulet is a company that builds this product called Omnipod. If you know anyone who has diabetes, they might have this. It's basically a little thing you put on your body, and it just automatically learns your blood sugar levels and how much insulin you have, and it automatically just releases the right amount for you using AI. You don't need to, stick yourself every day and have to worry about measuring it and all of that. Lots of these kind of, crisis text line is using, this technology to basically help people that are suicidal. It can automatically detect, it can help them. It's like basically been trained. The model has been just trained and optimized on basically helping folks that are, suicide prevention essentially. So there's lots use cases like this. Zipline is another company. They have these drones that actually go and drop food where it's needed. They've helped out in Africa a lot, in Middle East, in other regions, and it's all automated, like everything from the sort of self-driving mode to the weather prediction, all of that AI is, leveraging us. So there's so many cool use cases, and we're just scratching the surface.
Life-changing applications already being deployed. Amazing. I want to go a layer down. Let's talk a little bit about Lakebase, which you launched earlier this year. You shared that publicly that roughly 80% of databases on Neon have been deployed by agents. Is that right?
Yeah, so a year ago, 30% of the agents, 30% of the databases were created by agents. 70% were being created by database administrators, DBAs. This year, the number was 81%. I think next year is probably going to be 99%. So, people are just vibe coding, using things like Lovable, Replit, whatnot. And those things just under the hood will just use lake-based databases. And the agents use the databases differently from humans.
How so?
The agents they're much more parallel.
Yeah.
They like to experiment, create lots and lots of databases. You don't want to pay for all of the databases. So you want to make it really cheap so that, once they're stopped using it, it should shut it down automatically. So we basically built scale to 0. So within a second, we can shut down a database, and we can scale it up within 1 second as well. And you can get up to your millions of queries per second.
Wow.
Another thing, the agents, they're kind of experiment. So they take an existing database and they want to clone it and they want to do some things, but they might break the database. So you want to have really good branching, kind of like copy on write, sort of, for your database. And once you do the copy on write, you can do it very fast, right? You can 1 second or 2 seconds, you can clone petabytes of data, because under the hood it's actually just copy and write. Then you can iterate, the agent can iterate on the database. And then if it notices that, okay, this didn't work, it's not passing the tests, it can immediately just go back to an earlier snapshot. So basically, all that we've done is made sure that the database is really optimized for what this new user persona, which is the agent, needs to do on the database, and made it good for that.
You may have already answered my next question, but I'm curious kind of why the AI era needs a fundamentally different database architecture.
Yeah, I mean, look, I just think that we're going to see these agents more and more in everything that we do in computer science. So let's take database management. In many organizations, you have thousands of databases. And then you have humans running around. What are they doing? They're looking like, oh, why is this database slow? Oh, someone forgot to put the secondary index on this. Or that index is gone. It was blown away. Okay, we need to put the secondary index on this. Oh, why is the CPU consumption so high on this? A lot of this monitoring and management is done by humans today. I mean, these are great ideas, right? You can just build agents that do that for you. They can go look through your databases, manage them. There's a lot of tasks like that. So this is just picking databases as one example. But pick anything that we have in computer systems and see how people are managing them, how they're using them. And there's lots of ample opportunity to build agents that just automate and make that much more effective. We're literally just scratching the surface on it. So it's very exciting times ahead.
Exciting. I want to shift to open source. You mentioned it at the beginning. I mean, we have to talk about it. Berkeley is a home to open source. It seems that you maybe have some mixed perspectives on this in terms of whether or not someone should go into open source. What are the important considerations for students in the audience if they want to start an open source project, contribute to an open source project? What are some of the things they should keep in mind?
Yeah, I mean, I'm a big fan of open source. One of the reasons I came to Berkeley, I mean, BSD, Berkeley System Distribution of Unix. Many parts of internet was built actually at Berkeley, up on the hill, LBNL. They built congestion control. Van Jacobson built that. Basically, he avoided the internet collapse, before we were born. So there's a rich history of open source at Berkeley. I think we should continue leveraging that. The key thing to make sure is that when you open source a project, that your goal is to make it go viral. If you're not able to make it go viral, then you've basically shared your intellectual property with everyone for free. So then you've actually not accomplished anything. So really try to make a simple project, make it easy to use, make the documentation great, and make it usable by as many people as possible, and just make it go, you want it to kind of go, that's the whole point of open source is getting the adoption worldwide. And as you do that, you should probably also be careful with the license that you put on it. I mean, I think actually the license is fine. We put Apache, but who owns if you're giving it away to a foundation, make sure that you give it to a foundation that, is compatible with what you want to do with the project in the future, if you want to have a company around it or whatever you want to do. The second thing is, once it's gone viral, the project is super successful, it has millions of downloads, which can happen faster and easier than you think. So I encourage that. The question is, once you start, if you want to start to commercialize it, if you want to have a company around it, you need to think through an edge strategy is what I call it, which is, What's the kind of proprietary value around it that you're going to add on top of it so that you can also monetize it? Because if you can't monetize it, then it's going to be very hard for you to pay people and continue maintaining the open source project. So you want to build momentum, so that you want to have a business model around it. Like my example is the best business model. This doesn't kind of exist, but the best would have been if you invented Git and open sourced Git and then built a company called GitHub around it. That's like the perfect.
That'd be nice.
Yeah, you can think about it that way, right? Because Git was awesome. Everybody uses Git. It's like, but it's just the CLI. And then GitHub around it built a whole experience with, pull requests and it's kind of like essentially a social network for coding.
So we're running out of time here. I want to go back to some of the advice to students. For those that are thinking about, do I go into academia? Do I start a startup? Do I go into industry and deepen my technical skills? What advice would you give your 20-year-old self today?
Yeah, I mean, first of all, I think right now you should try to be as broad as possible because there's so much changes happening, and who knows, what's going to be, what's going to be popular, what's going to be a good job to have, what's the right thing to do research on. So I think no one really knows. Things are in flux quite a bit. I do think it's excellent time for starting companies because you're like basically, it's kind of like you're in the beginning of the internet. It's kind of like that, but even bigger, right? So I think it's just amazing opportunity to do innovation and start with it and just stick it out, and don't give up because you're going to have lots of challenges. At Databricks, we had many challenges. Like the Spark project itself started in 2009. It didn't go viral. We struggled getting companies adopting it. So it's one of the reasons we started Databricks was because many of the bigger companies didn't want to adopt it. So 4 years in 2013, we started the company. And then the next 2 years, we just struggled getting the world to listen to us. So it wasn't until 2015 the project took off. So that's 6 years in. And even then, we didn't have commercial success. So we had to spend another 2 years. So you're already 8 years in. So this is just perfect timing. Start now and believe in yourself and just keep going. Don't give up because it takes a long time. Like it's not like you start a company and you're going to have something like Databricks next year. I mean, maybe you will. I hope so. But if not, don't give up. Like just keep going. If you want to go to academia, I mean, if you really, really love research, which a lot in the past at least has been centered around, it's the research community publishing the papers. You have to really like that. It's kind of hard to be in research if you don't like publishing. So, do you enjoy the publishing aspect of it? If not, then maybe academia is not the best thing to do. So it kind of depends on what you get joy out of. Pick whatever. Like if you get more joy out of hacking, then do that. Because you're going to have a great future doing that.
What about deepening their technical skills at Databricks?
Yeah, you are welcome to Databricks as well. We are hiring like 3,000-4,000 people just in the next year. So.
Wow. And I guess just as these folks are making their decisions, how do you cut through the AI hype? I mean, there's just so much noise. There's so much BS. How do you figure out what is the right opportunity to pursue?
Yeah, I mean, just focus on things that are useful. Don't worry about the hype. Ignore the hype. There's just special. People are like chasing. Getting reactions on Twitter, or there's just so much. Things are getting overhyped on archive and so on. But just focus on simple, useful things. That's my advice. Like things that are just useful that you would like to have, but there's nothing out there that can actually do it for you. Build that, no matter how silly or small or mundane it is. Just do those projects and don't worry about if it's already been done before or if it's not cool or if you're not using the latest thing that everybody wants. Just do that. Just focus on that. Most people are not doing that. The vast majority of people are just, all just rushing toward what's hot. And everybody, it's like, herd behavior. The herd is all running towards like one objective. And then the objective moves to another place and everybody just goes in that direction. So if you just focus on things that are useful and ignore that noise, you'll be better off. And don't be stressed out by, everything that's going on in the background.
It's great advice. Thank you. I want to end on a fun one. Ali, what is your vision for the future of AI?
Ooh, vision of the future of AI. Yeah, I mean, I think that we're going to just see a lot of the stuff that you guys are developing here and others are going to develop in the short term. They're going to grow to be massive companies that are going to automate so much of what we have. I think education is going to be completely transformed. Like the like the way we were taught and the way we went through universities will probably be the last generations. I don't think that people are going to go to school like that. I think the way healthcare was done is going to be different completely. I think just the way businesses run, the way the world runs is just going to be completely transformed. And it's just simple things that you see every day in organizations that we are doing that you could automate and do differently. Just envision that and build that, and there'll be companies around that. So it's going to be super, super awesome. This is going to be like the greatest next 10, 20 years.
We've got an awesome future ahead. Let's give it up for Ali.
Thank you.